Hello, I'm Bradley, and this is Joseph, and together we are siblings in science.
So in this video we are this is like the first video I guess we're making. So the point of these is that we talk about a science topic, and I am a physicist by training. Bradley is a
Marketer.
So yeah, science communication marketer kind of person. So today we are going to go for a cheap shot and do one that's been completely overdone, which is the speed of light, special relativity, and what like time dilation is. I guess I think that's a good place. It's quite an interesting topic,
and I have no idea that we're going to study this topic. All I knew beforehand is that it was going to be
a cheap
shot idea so that we can get more people. Classic marketing spin.
Yeah.
And apart from that, there's no books underneath us.
Oh yeah, okay. Yeah, so anything I say, this is like a disclaimer in case people I know are watching this. Anything I say is from the top of my head. If you are using this for factual knowledge, that's the word, isn't it? If you're using this for factual knowledge, check it up in a book. I'm a fairly experienced physicist, so what I say should be right, but I may slip the tongue, etc. So,
whereas what I say is always right because I'm in marketing.
Yeah.
So what was the topic again?
Well, okay, let's do time dilation and length contraction. Okay. You can see this is not scripted, by the way.
Okay.
Time dilation and length contraction.
Yeah.
Length contraction.
Okay.
Okay. So
let's start with time dilation.
Should we start with time? Okay, let's start with time dilation. Okay, so first of all, we need to get a concept of speed. I'm assuming you know what speed is.
Yeah.
Describe to me what speed is.
Going really fast over a short distance. Going fast over a short distance.
So yeah, so going faster. You travel a certain distance in a certain amount of time. That is what we mean by speed. And there's one speed that is invariant. Do you know what invariant means?
Less likely to happen.
No. Okay. So this is a technical term. So invariant means that it doesn't change.
Okay.
If you change frames, it doesn't change. So imagine the typical example is if I am stood still and you are running. The thing I'm getting here is
this is usually the other way around. I usually stand still. He's usually running. But yeah.
Okay. So the thing I'm getting at is the speed of light.
Yeah.
So the speed that light travels is invariant.
Yeah.
So that means it doesn't change.
Yeah.
Depending on your velocity or depending on what frame you're in.
Yeah.
So if you're running at like 10 miles an hour, we're UK based, 10 miles an hour, then the speed of light you're going to measure is going to be the same as me.
Yeah.
About 3 times 10 to the 8 meters per second.
Okay.
So do you understand roughly that?
Yeah. So it's not going to change between us.
Yeah.
Because we're calculating the same thing.
Yes, not quite. So if you imagine a car going past you, imagine you're running at 10 miles an hour.
Yeah.
And a car comes next to you, and the car is also traveling at 10 miles an hour.
Yeah.
Relative to you, the car is stationary.
Yeah.
Because you are both moving at 10 miles an hour.
Yeah.
If the car is moving at 20 miles an hour and you are moving at 10 miles an hour, then the car relative to you is 20 minus 10 miles per hour, ignoring special relativity effects.
Yeah, I'm ignoring special relativity effects. Yeah.
So it doesn't matter at this low speed, but so you understand the concept of relative speed.
Yeah.
Okay, so once we go the speed of light, therefore, so if the speed of light is 30 miles an hour, and you're moving at 10 miles an hour, what would you expect the speed of light to be? So 30 minus 10?
20.
So that would be the naive answer.
Yeah.
But it's not. You would also measure it to be 30 miles an hour.
Okay. Because I'm moving relative to...
Not that you're moving relative to... This is quite an unintuitive effect. So you are stationary.
Yeah.
Then... Maybe I'm not explaining this very well, but you are stationary. Okay, so I'm stationary. I measure the car going past me.
Yeah.
I'll do it like this. At 30 miles an hour.
Yeah.
You are moving past me at 10 miles an hour.
Okay.
So naively, you'd expect the car to go past you.
Yeah.
At how fast? We just mentioned it.
20.
20. But it doesn't. If it's light, it travels past you at 30 miles an hour.
Yeah.
So it's counterintuitive.
Okay. Yeah. Yeah, but that's so if you're running it and I'm walking, then the car would seem to pass me faster than it passes you.
if it was a car, if it was light, it would pass me and you at the same
Same
speed.
speed. Okay.
As we experience it.
Yeah.
So that's what we mean by the speed of light. So it's a speed that we could, like, no matter what frame or no matter how fast you are going, the speed of light is always going to be the same. Do you understand that?
Yeah.
Okay. So that is the speed of light. And the way, because of this effect, because of the fact it doesn't matter how fast you're moving, the speed of light is the same, it means we get weird effects such as time dilation and length contraction. I keep mucking up saying length contraction because it's also called Lorentz contraction.
Okay.
So it's one of the
same, different words for the same thing?
Yeah, different words for the same thing.
Okay.
Some people also call it fancily Lorentz Fitzgerald contraction.
Very fancy.
So if you want to be fancy, call it Lorentz Fitzgerald contraction. I don't know who Fitzgerald was, but yeah.
Maybe that'll be your homework before the next one.
Yeah,
work to find out who he is.
What he did.
What he did. Why it's named after him.
Yeah.
Instead of just being Lorenz.
Yeah.
Why did he have to add a surname in there as well?
Yeah, I don't know. Well, I'll look that up.
Yeah.
I will look that up. Maybe not before the next video, but I will look that up. Okay, so you have time dilation, which is I think this video's going on for a long time already, so we're gonna cut. I'm only gonna do time dilation. So
time flies when you're talking about dilation,
and when you're moving really quickly. So this is what time dilation is. Okay, so Einstein put basically how you said time flies when you're in the presence of a pretty girl, and it goes really slow if you have like a long homework to do. That's nothing related to special relativity. I think
we can relate to both those things.
Yeah, well,
yeah.
Well. So that's not actually related to special relativity. It's kind of a misnomer that stuff like that is not. So basically, time dilation is this. If I have a watch, and so if I have a watch and I measure a certain amount of time, I'm trying to remember which way this goes around. But if I have a
so do you want some time? I'll count how much time it takes you to find out. Okay, you
find
ready?
out what? Okay, go. So if you are stationary.
5-6 seconds,
you're going to measure a certain time on your watch. Okay, let's put it this way. In your hand, you have a light bulb.
Yeah.
And that light bulb turns on, and then it turns off.
Yeah.
And you measure the time it takes for that light bulb. I'm just going to beat your hands up a bit. I'm going to measure the time it takes for that light bulb to turn on and off. Okay. And let's say you measure 5.6 seconds.
Yeah.
Then if I'm running past you at close to the speed of light, how fast do you think I'm going to measure it?
5.6 seconds.
Well, yeah, so that's what you would naively think, but it actually doesn't work like that. So if I'm running past you, I would measure the light bulb flick at a longer time.
Okay.
So it would be something like 10 seconds. Or 20 seconds, depending on how fast I was going. And if I was travelling at the speed of light, the world stops. Yeah. And everything takes an infinite amount of time. Check that. Because
this is a really weird way to hold a light bulb as well.
Yeah, there's a plug, by the way, going down here. Just like... Okay, so this is what time dilation is. Time slows down. Yeah. If you move fast. Yeah. The way to remember that is the word dilation means expand. And okay, so
time slows down if you move fast, but if you watch this video,
relative to
time would slow down even more. Cheers for your time. We're gonna have another one fairly soon, and and hopefully, I mean, we can probably guarantee it's going to be better than this pilot.
This is like and we don't know how we don't know what we're doing basically. This was the first one. I think it went.
I think it went okay. Comments below if you have any suggestions on next topic.
We just got a thing saying one of our parcels is
sorry, Amazon's delivering our picture hooks for
not my picture hooks. Okay,
so follow us online, www.
Wait, I'm going to stop this. It's exactly 10 minutes.
In science.com or at